Hello everyone, welcome to Learn Wireless Technology. In this tutorial, we will talk about the features of different LTE releases in little more detail. LTE, as we know, was introduced in Release 8 and it kept on evolving with every release up to Release 14. So we will discuss about the features and improvements that were introduced in each LTE release. So we'll start with the features of Release 8 LTE. LTE uses a flat all-IP architecture. It means that LTE has fewer network elements compared to the legacy 3G network. The base station in 3G is replaced by eNode B in LTE, and there is no radio network controller in the radio access network of LTE. And due to fewer network elements, the latency is reduced, which reduces the signaling time, providing high spectral efficiency. The operating frequency range is between 700 MHz and 2.7 GHz. So LTE supports scalable bandwidth, which means user will be allocated with a range of different frequency bandwidth as per the demand. The available bandwidth for deployment are 1.4 MHz, 3 MHz, 5 MHz, 10 MHz and 20 MHz. The bandwidth allocated to a user can be any one of these available bandwidths. LTE supports MIMO, which stands for multiple input, multiple output. It is a multi-antenna technique used at both transmitter and receiver for transferring multiple streams of data over a wireless channel. With MIMO technique, the spectral efficiency is improved. Now this term spectral efficiency is coming up many times and will come up in future slides and tutorials as well. So it basically means that for communication over a radio channel or for transmitting data, we have a range of frequency band or spectrum defined that is allocated for wireless transmission. Now that spectrum or frequency range is very limited and we have already utilized most of the available bandwidth in that range. Hence it is quite necessary that the spectrum is used as efficiently as possible and the bandwidth is not wasted. Hence spectral efficiency is one of the most important features offered by LTE. LTE provides both FDD and TDD solutions which supports operation in paired and unpaired spectrum respectively. In case of FDD, there are two different RF carriers used, one for uplink transmission and one for downlink transmission. Uplink and downlink transmission happens simultaneously in FDD. And in case of TDD, the same RF carrier is used in both uplink and downlink direction. Hence, simultaneous transmission cannot happen in case of TDD. If we talk about the frame structure, then FDD uses type 1 frame structure, where the entire radio frame can be allocated for a user for either uplink or downlink transmission, whereas TDD uses type 2 frame structure, where the subframes in a radio frame are partially distributed for uplink and downlink transmission for a user. Hence, in the FDD mode, we can experience high throughput rate compared to TDD, since in FDD, the data transfer can happen continuously in both the directions. The access technology used in LTE in the downlink is OFDMA, that is orthogonal frequency division multiple access, and in the uplink it uses SCFDMA, that is single carrier frequency division multiple access. SCFDMA is also called as DFTS OFDM, that is discrete Fourier transform spread orthogonal frequency division multiplexing. OFDMA is a form of frequency division multiplexing where large number of narrow band closely spaced subcarriers are used to carry data. These subcarriers are spaced in such a way that orthogonality exists between them despite being closely spaced. This eliminates the interference between the signals carried on different subcarrier. It also eliminates the need of guard band between the subcarriers, which in turn increases the spectral efficiency. Modulation techniques used in LTE are QPSK, 16 QAM and 64 QAM. The modulation type used specifies the number of bits that can be accommodated in an OFDM symbol. Higher the modulation scheme, higher will be the data rate, since each symbol can carry more number of bits. LTE has only packet switched network. There is no circuit switch domain in LTE. Even the voice calling service goes over PS network, which is known as Voice over LTE or VoLTE. In case VoLTE is not present in any area, or the service is not activated in the SIM card, or if the VoLTE option is disabled in the device, then the device will fall back to legacy circuit switched network to make a voice call. This feature is known as CSFB, or circuit switched fallback. The legacy network can either be 3G or 2G. LTE also supports SON, that is self-organizing network, which supports automatic configuration and optimization of new cells to reduce cost of installation and management. It minimizes the operation costs by eliminating the manual configuration of network parameters at the time of network planning, deployment, and optimization. Home eNodeBs and femtocells are low power nodes that are installed in residential or enterprise building. It is like those Wi-Fi routers that we install at our homes and offices, but they use unlicensed spectrum for transmission, while Home eNodeB uses licensed spectrum. It improves capacity by offloading traffic from macro cell and enhances user experience. So with these features, the Release 8 LTE can provide theoretical data rate of up to 300 Mbps in downlink and 75 Mbps in uplink. Now in Release 9, a new feature called eMBMS, that is Enhanced Multimedia Broadcast Multicast Service, was added. eMBMS is a feature that offers same multimedia content to multiple users simultaneously in a cost-effective way. There are control and traffic channels defined at lower layers specifically for transmission of multimedia services to support eMBMS. Another new feature added in Release 9 was LCS. LCS is referred as Location Services, which supports positioning methods. Let's have a look at what are those methods. AGNSS, that is Assisted Global Navigation Satellite System. This method uses the UVs that are capable of receiving GNSS signals, for example GPS and GLONASS. OTDOA, that is Observed Time Difference of Arrival. This method uses the time difference of times of arrival of downlink signals from multiple eNodeBs at the UV. EID or Enhanced Cell ID. This method uses the information such as propagation delay and angle of arrival along with information of serving eNodeB and cell ID. LPP, that is LTE Positioning Protocol. It is a control plane application protocol standardized for LCS feature. Then there are enhancements to Home eNodeB and self-organizing networks, additional MIMO flexibility and multi-layer beamforming to support higher peak data rate in downlink direction. For end-to-end voice support, we discussed about VoLTE solution before, and apart from voice calling, Release 9 also provides emergency attached procedure for making IMS emergency calls. Vocoder rate adaptation, which allows control of voice coding rate as per the quality of radio channel. And there were some improvements in CSFB, such as more robust signaling for making the fallback procedure to CS network faster so that less time is taken to establish a voice call. Release 10 is referred as LTE Advanced, which meets the actual LTE requirements standardized by ITU, that is International Telecommunication Union. We discussed previously that though LTE was introduced in Release 8, it couldn't meet the requirements defined by 3GPP. So after introducing new enhancements and features in later releases, the performance of LTE improved and it could finally meet the actual LTE standards in Release 10 version. The enhancements that Release 10 saw are higher capacity, increased peak data rate, that is downlink speed up to 1 Gbps and uplink speed up to 500 Mbps, then higher spectral efficiency and improved performance in a cost-efficient way. The two major factors that saw such enhancement in data rates are carrier aggregation and advanced multi-antenna techniques. So the principle of carrier aggregation is to extend the transmission bandwidth to maximum up to 100 MHz. Now in Release 8, the maximum bandwidth the network can provide is 20 MHz with single carrier. But in Release 10, the carrier aggregation allows to transmit using bandwidth up to 100 MHz. This is done by adding secondary component carrier to the existing primary carrier. So up to 4 component carriers can be added, which would increase the transmission bandwidth up to 100 MHz, hence increasing the data rate. And the second factor that supports high data rate is enhanced MIMO. Enhanced MIMO supports antenna configuration of up to 8x8 in downlink and 4x4 in uplink. It also provides high spectral efficiency and increased capacity. Further system improvements added in Release 10 are heterogeneous network, which incorporates small cells such as micro, pico, and femto into the macro network. It increases capacity, throughput, and coverage. The main goal of heterogeneous network is to offload the traffic from macro network. Relay nodes also supports to increase coverage and flexibility. Relay nodes can be thought of as a low-powered node base connected to the network. Basically, they are effective in extending network coverage where users will be provided with increasing throughput in areas such as malls, offices, stadiums, parking, etc. With the addition of features like heterogeneous network and relay nodes in Release 10, there can be strong interference between signals from different cells due to varying power levels from small cells. Hence, an advanced interference management technique is required. eICIC, that is Enhanced Intercell Interference Coordination, fulfills this requirement. eICIC is a technique in which high-power nodes such as macro cells transmit data in limited subframes while the low-powered small cells transmit data in the other subframes. Release 10 also supports seamless interoperation between LTE and WLAN to offload the traffic to unlicensed spectrum. Since carrier aggregation was the most demanding feature introduced in Release 10, it was obvious that it will keep on developing more. Hence, in Release 11, there were further enhancements to this feature. Non-contagious intra-band carrier aggregation was included in Release 11, where the carriers of adjacent frequencies are used in combination. There were other multiple band combinations added in Release 11 that provided wide range of options to use carrier frequencies to aggregate that would increase the data rate. There was further improvement in intercell interference coordination. The main purpose of ICIC is to keep the intercell interference under control, taking into account the information such as radio resource usage status, traffic load situation, etc. The main enhancement in Release 11 was to provide the UE with cell-specific reference symbol information of the cell in order to help UE mitigate the interference. Again, there were further enhancements in SON. Now, coordinated multipoint operation, also referred as COMP, was a new feature introduced in Release 11. COMP aims at reducing the intercell interference for cells that are operating on same frequency. Intercell interference occurs mainly at the cell edge in a network deployment that has a heterogeneous topology containing mixture of micro, pico, and femto cells, alongside a homogeneous topology containing single macro cells. COMP allows the optimization of transmission and reception from multiple cells in a coordinated way. Release 11 introduced a new channel called EPDCCH, that is Enhanced Physical Downlink Shared Channel. This channel is used to support the new features like COMP and Enhanced MIMO. The addition of this channel was one of the major enhancements in Release 11. Moving on next, LTE continued to evolve in Release 12 as well, by adding new enhancements and improving the existing ones. There were enhancements in small cells which aims at improving mobility robustness, reduce signaling load, and enhance user throughput. 256 QAM modulation was added in Release 12 due to widely used small cells in network deployment. The increased use of small cells results in high signal to noise or interference ratio at user end. This issue is addressed by adding 256 QAM modulation. With 256 QAM modulation, overhead reduction, and control signaling enhancement, the spectrum efficiency is improved. The dual layer connectivity feature was being studied, which resulted in this feature called dual connectivity, where the UE is allowed to use radio resources from two different eNode Bs. In dual connectivity feature, there will be two different carrier frequencies from two different network nodes. UE will be provided radio resources from each node with different MAC scheduler, and UE needs to support two uplink carriers. Device-to-device proximity services. In this feature, the devices in close proximity will be able to detect each other and communicate directly without any network intervention. The objective here is to reduce the network load. Then network assisted interference cancellation and suppression. Then further downlink MIMO enhancements. Again, this feature is required to achieve higher system throughput with different antenna configurations. We saw the introduction of COMP in Release 11 to improve the capacity and coverage at cell edges. But in Release 11, the transmission was allowed only between the nodes that were connected to an ideal backhaul. There was no use of the actual interfaces between the nodes. So in Release 12, the X2 interface between the nodes was specified to use COMP, where multiple eNode Bs are coordinated by inter-eNode B signaling. FDD-TDD carrier aggregation. Earlier we had seen carrier aggregation mostly using FDD bands. Now, since the operators hold licenses for both FDD and TDD spectrum, it was decided to use both paired and unpaired spectrum, that is FDD and TDD, in Release 12 for carrier aggregation to allow more data throughput. Release 12 also allows integration of Wi-Fi with mobile operator offerings. It basically supports interworking between WLAN and 3GPP. Since WLAN operates on ISM band, which is unlicensed spectrum, it is a good idea to use this spectrum to offload traffic from LTE frequencies. Release 13 included a lot of new features in addition to enhancements to the existing features and services. The use of unlicensed spectrum was one of the major goals in Release 13. Though the licensed spectrum use was the top priority, but using the unlicensed spectrum was also equally important to meet the growing traffic demands. LAA, that is, Licensed Assisted Access, is one of the solutions to the use of unlicensed spectrum that has potential of cost saving, improved spectral efficiency, and better user experience. The focus is to use the licensed spectrum of 3GPP as primary cell and unlicensed spectrum of WLAN as secondary cell and aggregate the two cells to increase the throughput. The carrier aggregation introduced in Release 10 had the capability to add up to 5 component carriers in downlink and uplink. The Release 13 carrier aggregation was standardized to expand the feature by using up to 32 component carriers. This provides much higher achievable data rate. For LTE devices to be suitable for IoT markets, the Release 13 provides an enhancement to machine type communication, which focuses on defining a new low complexity UE category. The new UE category type would support reduced bandwidth and reduced transmit power for downlink transmission, along with long battery life using power reduction technique. As an enhancement to device proximity communication, Release 13 included support for more advanced proximity services focusing on public safety and user application purposes. To address the future capacity demands, LT Release 13 identified elevation beamforming and full dimension MIMO as the key technologies. With higher order MIMO, the antenna configuration at eNode B shall support up to 64 antenna ports. With multi-user transmission technique, the spectral efficiency of the LT systems can be increased. Indoor positioning determines the performance of positioning method in indoor environments and evaluates the potential improvements to achieve better positioning accuracy. The eMBMS feature allows transmission of multicast services via multiple cells. SCPTM allows support for multicast services over a single cell. LTE Release 14 provides a roadmap for 5G development. The main features that paves the way for 5G technology are reduced latency, use of unlicensed spectrum, massive machine type communication, massive MIMO, etc. Along with the LTE release evolution, a new 5G radio access technology will be developed. Let's have a look at some important Release 14 features. Support for V2X. V2X is basically vehicle to everything. It is a concept of connected cars the vehicle industry could implement using the widely deployed LTE network. A vehicle can be connected to internet and other vehicles so that a broad range of applications and services can be implemented, such as proximity safety services and commercial applications. Enhancement in licensed assisted access, that is LAA feature. This feature specifies the support for uplink carrier in LAA secondary cell operation in unlicensed spectrum. We discussed about LAA in previous releases where the LAA support was for downlink carrier. In release 13, for carrier aggregation, the secondary cell operation used the unlicensed spectrum for downlink transmission. Now release 14 will have support for uplink carrier aggregation for LAA, where the uplink carrier for secondary cell operation shall be in unlicensed spectrum using frame structure type 3. LTE WLAN aggregation support is similar to release 13. The enhancements in release 14 includes support for uplink data transmission on WLAN, mobility optimization such as intra and inter eNodeB handover without changing the WLAN terminal. It means that when the UV is connected to LTE and WLAN at the same time, then during handover when eNodeB is changed, the WLAN terminal should stay connected. Carrier aggregation using 4 different bands, providing more number of band combinations for CA activation. Interband carrier aggregation supports the use of component carriers in different operating bands. The carriers in each band can be contagious and non-contagious. Enhancements in eMBMS. The eMBMS feature, as you know, is a multimedia broadcast multicast service which delivers multimedia services such as video streaming to multiple users. For eMBMS, the earlier releases support transmission using 7.5 kHz subcarrier spacing with cyclic prefix of 33.3 microsecond. The objective of eMBMS in release 14 is to use larger cyclic prefix which is greater than 33.3 microsecond in an environment with larger delay spread. So with this we come to the end of this tutorial. I hope you understood the features of different LTE releases and how the technology evolved with improved performance after each release. Thanks for watching.